Okay, so the last problem you guys are going to look at today is a contextual word problem here. So this is a ball's thrown. We're on this planet, so that means that we're dealing with that s of t equals negative 16, right? T squared plus the initial velocity t plus the initial position. That whole situation, right? And so we know that the derivative, which is velocity, is negative 32t plus the initial velocity. And we also know that the second derivative, which is acceleration, is just going to be that gravitational constant of negative 32. Okay, so let's see what they give us. The ball is thrown downward from a building such that its downward velocity at 1 second is 76. Okay, well, that's telling us that the velocity at 1 second is equal to 76. Now, I use a negative because we say we're going downward. That's going to be important. Another way I could have written it is s prime of t equals negative 76, right? We should know the relationship between the position function and velocity. And then it says it's 10 feet above the ground at 2 seconds. Okay, well, that's just telling me that my original position, my s function, at 2 seconds is equal to 10. Okay, and now if you notice here, these problems now become exactly like the ones above, right? Where we're given an initial condition, we've got the starting acceleration, we can go backwards and get all the way up to these functions. So what is the ball's initial velocity? Again, we know that the acceleration is negative 32. So, and I'm going to use dt to represent this because now we're doing integrating time, right, not x's. Okay, so when I do this here, I'm just going to take the integral, and this is going to give me my first derivative because this we know is a of t, which is the same thing as s double prime of t. Okay, so when I integrate, it should give me v of t, or v prime, no, s prime of t, okay? So what I'll get is negative 32t plus c. Now look, we already knew that because we, had this formula memorized from before. This is just my velocity formula here, where this is my initial velocity. Well, this is what the c is representing, the initial condition, right? So we have that right here. Should be a 1. Okay. So I'm going to take this v of t equals negative 32t plus c, and I'm going to use this s prime, right? Because we know that these two are the same thing. So t is 1, and it's at an initial position of negative 76. Well, its velocity is that. So 32, I'm going to add 32. Those will go away. My c will equal negative 44. Okay, so that means that my velocity function is this. Okay, and again, the question was asking for what is the ball's initial velocity. So that just means when time is 0, right? We're just looking, this is saying we're looking for v of 0. So I'm just going to plug 0 in, and again, it's just going to be that constant that we just saw for, 0. That goes away, so we know that v of 0, negative 44. We should put some units on that, feet per second. And this just means it's traveling downward, right? Okay. How tall is the building? So that's just asking, right, for the initial position, because it's saying it's thrown downward from a building, which means that at time 0, right, we want to know where our object is, so s of 0. So again, I have to do the same thing, but I just need to integrate using this, using my velocity function, right? So I've got the integral of my velocity function, which we just solved for right here. Okay. Negative 32, sorry. Okay. When I integrate, I should get negative 32 t 1 plus 1 over 1 plus 1 minus 44t plus c. And this now represents our initial, that represents our original function, that position function. Okay. So if I simplify this, I'm going to get negative 16 t squared minus 44 t plus c. And again, the last step here before we get our height is just using this initial condition. So time of 2 we're solving for c, so this equals 10. Okay, I'm running out of space here, so I'm just going to do this out for you guys by hand. Okay, so give me a second. Okay. So I got a C of negative 142. Okay. Now I might have done something wrong here. I also might have done this number wrong up here. It's not, I'm not, it's quite early. Okay. So I'm going to rewrite this position function, s of t equals negative 16 t squared minus 44t, and now we've got this minus 142. Okay, and so the last part, how tall is the building? Okay, so at s of 0, what's going to happen? All this, I forgot the t again. All this part's going to go away, and so my position should be, you know what? This should be 162. That's what I did wrong. And it should be positive, because you can't have negative height. I subtracted wrong. Okay, so this is 162, that constant, right? So that means that when I find my initial position here, that's what we should get. Okay, alrighty.